ちょっと無理をすると風邪ひくかもしれないんで、ちょっと今日はここで終わります。ここまでしか行けなかった。この辺まで。これを大宝山を目指したんです。風邪をひくかもしれないです。残念。
Thank you for a very interesting talk. I think I heard you say that you're more optimistic about overhearing a communication than receiving a signal deliberately broadcast. The little ETs basically say, yes, we're here. Now, the trend in communication seems to be towards spread spectrum and encoding and encryption and all these things. So to paraphrase Arthur Clarke, it seems to me any sufficiently advanced communication is indistinguishable from noise.
That's a very astute question. I bet you're a Silicon Valley radio engineer. If you go back to that plot that I showed of the radio power leaving the Earth, you might have noticed, the clever people might have seen that we were growing very fast. We're still growing exponentially, but the exponent has changed. We're not growing as fast. We're not. The radio power leaving the Earth is still going up. But maybe, as your question alluded to, that maybe eventually Earthlings will not be sending so much stuff out into space. Maybe we'll be more efficient about it. We'll go to very direct communication with fibers, and right now these television signals are broadcast every which way, which is kind of a waste of power. And then, as you pointed out, we're going to broadband communication, kind of split spectrum communication. Those kinds of communications, as you pointed out, are much harder for us to detect. The narrow band, the original kind of TV broadcast, FM broadcasts are relatively easy for us to detect. If they're all doing spread spectrum, that's going to be a hard thing for us to find. Of course, if they're doing it deliberately, then they're not going to deliberately kind of spread their signal out over lots of different frequencies. So radar signals, on the other hand, will probably be kind of a lot of power at one frequency. Maybe they'll have some kind of thing that looks at their spacecraft going around their planet, or making sure that asteroids aren't going to smash into their planet, or something like that, some kind of radar thing. That might be easier to detect than this advanced communication that you're asking about, which could be very hard for us to detect.
Thank you.
3 more questions.
I was wondering, earlier on you talked about scanning galaxies, and that really surprised me because it seems like they're very far away, the signals will be very faint. What's the rationale for doing that versus just focusing on our own galaxy?
Yeah, that's a very interesting question. Should we look at kind of the nearby stars because the signals are maybe stronger, or should we look at more distant things? The advantage of looking at something far away like a galaxy is that there are a few hundred billion stars in a galaxy, so just in one telescope pointing, you look at 100 billion stars, but then the signals have to be much stronger than the nearby stars. So this is a question about how advanced civilizations are. Are some very advanced, and are some not so advanced? Maybe they're just emerging like us. We don't know the answer to that question. So some people think we should look at far away things, look for the very brightest advanced civilizations. Some people think we should. If you look at the nearby, if you look out at night at the stars, the brightest stars are not the nearest stars. It turns out, because some stars are much brighter than other stars, it turns out that the bright stars in the sky are not nearby. They're just because, although they're these incredibly bright stars, thousands of times brighter than our sun, they're much rarer. But those are the ones that are the brightest stars in the sky. They're much further away than the nearby stars. The nearby stars tend to be very dim, and some of them are just, you can't even see them even though they're really nearby. They're just way dimmer than the sun. So AT might be like that. Maybe the first thing we find will be a super advanced, super bright, powerful civilization that's way far away, or maybe it'll be in our own backyard. We don't know.
Thank you very much for the talk. So assuming if we don't hear anything from ET in the next 5 to 10 years, there's a bunch of people saying that we should send out microsats. You're hearing all they're saying, all right, let's just throw hundreds of thousands of these like thumb-sized satellites. My question is, should we go for things that systems where someone thought it was a Dyson sphere, or someone the TRAPPIST thing where there's just a bunch of potentially habitable planets? What are your thoughts on how do we target?
Yeah, I wish I knew the answer to that question. My personal philosophy is that we don't know what the right thing to target is. We used to think that we should target nearby stars that are like our sun. We call them G-type stars that are a few billion years old. But now we know, just kind of recently, that there could be planets going around the most common kind of stars that are much dimmer than our star, these dwarf stars, and the TRAPPIST, this planetary system that was just started as 7 planets going around this little dwarf star. And 3 of those planets are good. So now I think, and some people also agree with me, that we should be targeting lots of different kinds of stars, and not just stars that are just like our sun. It may be naive to think that you have to have something just like Earth and just like our star to get life started. And so I think the best strategy in SETI is a multiple strategy. Don't put your eggs into one basket. In one basket, try look for infrared signals, radio signals, different kinds of frequencies, different kinds of signals, lots of different targets, because it's very hard to anticipate what another civilization might be doing. An example of that is the experiments that I showed you that were dreamt up 200 years ago. Now we think that's silly, like mirrors and smoke signals and stuff like that. And so if you ask me 200 years from now, it might be something. Maybe people will be laughing at what I was talking about right now 200 years from now. So we gotta kind of think outside the box and try a lot of different strategies. This is my kind of personal philosophy on that. I think we have one more question.
Thanks for the talk. So you mentioned that for the next 10 years of the LISTEN project, you would be using telescopes completely from places, one in the Tecumseh Tree, one in West Virginia, the other one in Australia, and also the array of telescopes in South Africa. So is there any plan to build an array of integrated telescopes located in different parts of the world that would talk to each other and also scan different parts of the sky?
Yeah, that is an interesting question, because this problem of radio frequency interference is getting to be a more this radio pollution coming from our civilization is getting to be harder and harder. So we think that one of the ways to solve that problem is just what you said. If you have 2 observatories far away from each other, maybe on different continents, and they're both pointed at the same star, and both of those observatories pick up the signal, then we can be pretty confident it's not from our human civilization. That kind of experiment where you have 2 different telescopes is kind of an expensive thing to do right now. It's a tricky thing to do, but it's something that I think we're going to need to do. And one of the next experiments we want to do in SETI is use this thing in South Africa that's made of lots of telescopes, and we can begin to kind of do that. Although it's not widely spread across different continents, it is spread out over many kilometers, and that will help us figure out what's interference and what might be a candidate signal from another civilization. So I wanted to thank you, and I wanted to say that if you have more questions, I'm happy to answer them informally if you want to come up. And somebody asked about other breakthrough projects and mentioned the Starshot thing. This is another thing that the Breakthrough Prize Foundation is funding, which is this idea that you can get to a nearby star, in this case Proxima Centauri, the nearest star that's 4 light years away, and you can do it by putting a sail in space and using this very powerful laser to propel this sail. It's about 4 meters across, and you put this incredibly powerful 50 gigawatt laser on that sail for about 2 minutes. 20 years in your lifetime, and send back images of exoplanets on the nearest star. So that's called Starshot. That's a very exciting new program. Don't hold your breath on that, but it's a fun new thing. Thank you very much.
evening, everyone. My name is Andrew Fracknoy. I teach astronomy here at Foothill College in Los Altos Hills, and it's a great pleasure to welcome everyone here in the Smithwick Auditorium and everyone watching us on the web to this very special lecture in the 17th year of the Silicon Valley Astronomy Lecture Series. This program, like all the others, is co-sponsored by 4 very worthwhile organizations: NASA's Ames Research Center, one of the premier NASA centers in the country, the Foothill College Astronomy Program right here in Los Altos, the Venerable Astronomical Society of the Pacific, a public education organization doing in all their programs what we do here in the lecture, reaching out to people about the wonders of astronomy, and then the SETI Institute, the Search for Extraterrestrial Intelligence Institute, a scientific and educational organization devoted to discovering more about the presence of life elsewhere. So we hope that you will give credit to those organizations, and it's my pleasure on behalf of all the sponsors now to introduce our distinguished speaker, Dr. Chris Impey. And I think of Dr. Impey as the closest we have in astronomy to a Renaissance man. He's really done just about everything it's possible to do in our field. He's had a distinguished research career with many scientific papers. He's been a respected college teacher, but he's also done research on astronomy education. He gives talks like this, and he writes textbooks. He has a video course in astronomy, and he writes popular books. And just if that isn't enough, he's also written a science fiction novel, and with his wife, an artist, he's doing astronomical art. So it just leaves me breathless to say all those things. So let me introduce him more formally now. Dr. Chris Impey is University Distinguished Professor of Astronomy at the University of Arizona. He's Associate Dean of the College of Science there. He has won 11 teaching awards. He was selected as the Arizona Professor of the Year and has been heavily involved in curriculum and instructional technology development. He served as Vice President of the American Astronomical Society. He was a Distinguished Teaching Scholar for the National Science Foundation and a Phi Beta Kappa Visiting Scholar. He works to convey the excitement of astronomy in writing as well. He has written over 40 popular articles on cosmology and astrobiology and 2 introductory textbooks. He's the author of 7 popular science books, including one directly related to the topic of our talk tonight, a book called Beyond Our Future in Space, published by Norton. So that is, in fact, his topic tonight. What is going to be our future in space? And there's no one I can think of to introduce this topic better than Dr. Chris Impey.
Thanks very much. It's a great pleasure to be here, and this is one of the most distinguished and venerable series of public popular talks in astronomy, so I'm following in an illustrious tradition. So yes, I want to talk about the future of space travel. It's not my research field. My research is on observational cosmology, distant galaxies and supermassive black holes, and generally, if it's less than a billion light years away, I don't really care. Everything I'm going to talk about tonight is much closer than a billion. It's worth conveying why space travel is an extreme challenge, especially. So let me just give you the handy scale model, something that you can use, next time you're in a supermarket in a long checkout line, you can regale the person behind or in front of you in the line with scale models of the universe, and at some point they'll start to look at you rather strangely, but it's a way to occupy time. So you have the Earth to the size of a walnut, the Moon a pea at arm's length, and on this scale, the Sun is, across the courtyard, 100 meters away at 3-meter ball, and the solar system is to periphery of Los Altos, our little town that we're sitting in, and what matters is that the nearest star is not even on the Earth. It's 30,000 miles away. So that gives you a sense of solar system scales compared to interstellar scales, and you can understand right away, without wanting to pour cold water so early in the talk, that all the Star Wars, Star Trek fantasies of interstellar travel are going to be extremely challenging with distances of this scale. Also, to give a little perspective, if you want to go to the stars, remember that this little journey, this from the walnut-sized Earth to the pea-sized Moon, in current dollars, this costs about $70 billion to get 24 people there. So it's also expensive. It's hard and it's expensive. So that's the context. But let me go back at the beginning, at least, to why this is even interesting, or really more fundamentally, why we do it. And to reference this, I'm going to show you an amazing map that's emerged from the research of the last few decades, which reveals through genetic analysis of existing populations on the Earth how we moved across the planet after leaving Africa. And so you can see the trajectories of how we radiated across the planet to all the continents. And what's striking is this took very little time at all. Look at the time, a couple of thousand of years between going across the land bridge of the Bering Strait, because there was land, you could walk from Russia to Alaska, all the way down to the southern tip of Patagonia, a few thousand years. So this is an extraordinary human migration in a few hundred generations. And remember, hunter-gatherers, small nomadic tribes, bands of 50 to 100 people, living by their wits with no technology. That's an extraordinary migration. There are animals that obviously travel large distances and migrate birds, particularly, but other species, whales and so on. And they do it with the rhythm of the seasons, and sometimes they do it for food sources. But humans are the only species that have migrated across the planet with no immediate need to eat. They're doing it out of curiosity. Of course, I look at this graph, especially the move across the Americas, and I notice that in the middle of this migration from the cold of Alaska to the bitter cold of Patagonia, they actually came somewhere around here. They went through Southern California, Northern California, and I'm sort of thinking, why didn't they just stop there and say, this seems kind of nice, we'll stay here? No, they just were driven by curiosity to go further. The research now is interesting because genetic analysis of these same existing human populations shows a correlation in this graph. This, for science, is a reasonably good correlation between the incidence of an allele or variation in one particular gene with the amount of thousands of miles that different hunter-gatherer groups or modern nomads have traveled in their journeys. And so what it's showing is that this variation of a single gene correlates with the amount of migration. And this has been dubbed the explorer gene because of this. This gene also correlates with certain other aspects of human behavior. It associates with ADHD behavior, with risk-taking. If you survey people who do, use wingsuits or jump out of planes or parachute, you'll find a higher incidence of this gene. So this is an interesting genetic component to the exploration urge, the itch we have to explore, saying that it has a genetic basis. Now, I'm not going to pretend to reduce genetics to one gene and say this is the reason we explore and other animals don't, and that we do this because we have to. But it's pretty intriguing research, and it becomes a basis for our exploration of space. We've explored the planet almost as much as we're able to, and that itch to explore continues. It remains. It's built into us. I'm not going to give a history but I'll just mention a few landmarks. The first punitive astronaut was Wan Hu, a minor functionary in the Chinese dynasty of sort of Shakespeare and Leonardo's time, actually. On a command from Wan Hu, 37 servants walked forward with matches and lit 37 large fireworks attached to his bamboo sedan chair. And according to Chinese legend, Wan Hu became the world's first astronaut. In practice, of course, Wan Hu died a hideous and horrible death. But that's not how it's written up. But he wanted to explore the stars. So this desire, this urge to explore, goes back a long way. And when it's hard to project how this will change. I'm going to use this example for the difficulty with which we can project forward in time. Because look at that little rocket of Robert Goddard in 1926. The rocket, most of that is the flame. The rocket is the little thing on top. It's a liquid rocket fuel, the same kind that we still use today. And in 1926, it traveled 132 yards across a frozen cabbage patch of his Aunt Effie's farm. And that was it. That was the beginning of space. And it's hard to go and project from that to getting to the moon. But that's how it starts. It starts with the visionaries and the pioneers. And then another unsung hero. I want to pick out unsung heroes. In this case, a heroine, Miss Baker, a spider monkey, was the first primate in space in 1959 at the dawn of the space age. Miss Baker survived. Some of the animals first sent into space did not survive. Miss Baker survived and lived to the ripe old age of 27, which is old for a spider monkey. And Miss Baker was buried at Goddard Space Flight Center with essentially military honors, and 3,000 people went to Miss Baker's funeral. And I think any of us would be lucky to have 3,000 people at our funeral. And then, of course, we recall that the early history of the space age and the space race was a rather strange history, and it's sort of a wide, sort of noble genetic urge to explore that's present also in the science fiction and the popular culture. But really, the space race started out of the depths of the Cold War and a geopolitical pissing contest between the two world superpowers. And those of you old enough to remember will realize that the United States lost in almost all of the first landmarks. The Russians were the first to launch satellite Sputnik, which scared people enormously, even though it was far too small to possibly hold a nuclear weapon. It raised the specter of nuclear weapons in space. And remember, this is the depth of the Cold War when nuclear weapons were being built at a huge rate. The first Russian, the first man in space was, of course, a Russian, the first woman, the first spacewalk, and you can go down the list. So for most of the first decade of the space program, the Russians were essentially kicking our butt. Things changed, but the backdrop for the space race and the intensity of it, rivalry with the superpower. Here's the words of Alexei Leonov from the third year of space. Now that's in retrospect and in hindsight, but in the moment, Leonov nearly died 3 different ways. His spacesuit malfunctioned, and when they got him out of it, he had sweated to the point where it filled his boots up above the ankle. The airlock malfunctioned, and he was within a few seconds of not making it back alive into a space capsule. So it's just dangerous stuff back in the early days. But what an extraordinary feeling or sensation to be the first person above the planet, hovering, waveless, looking down on the whole thing. We also recognize that with the benefit of hindsight and with the mythologizing of Hollywood and the media, some of it takes on a mythic tinge, and you'll see this very clearly in the next movie clip from a movie that I'm sure you're very familiar with. To try and look at it through the lens of how the space race started and how we sort of tell the stories looking backwards. So there is a mythic quality there. It's a bittersweet story, of course, because Apollo 13 was a failure. Those astronauts never set foot on the moon as intended, and they lived back home barely with their lives. And those of you again who can remember will recall that the last 3 scheduled Planet Apollo missions never happened because the budget was cut back and they were canceled. So the public's attention span on the Apollo program actually lapsed, and there was another reason for that that I'll get to. But the strange thing is that we live in a situation where this has become a dim cultural memory because it is so long ago. Gallup polls show clearly that about 7% of the American, 7 to 9% depending on the poll, of the American public don't think that it happened. They don't think that we went there. Think it's a conspiracy theory that we're making it up, that it was faked by NASA. And that's a very strange thing. As an educator, I'm torn on that one because part of me gets extremely pissed off to think that people will be so willfully ignorant about something that is essentially human's greatest technological achievement, period. On the other hand, if I think of a list of the batshit crazy things that 7% of Americans believe, Kennedy, conspiracy theory of Kennedy, Elvis, we saw him in the supermarket 3 weeks ago, at the 7% level, people believe so many amazing and weird and crazy and obviously wrong things that maybe you shouldn't get all bent out of shape out of it. So obviously when I teach, I try and show that there is still evidence left behind on the moon. We've been doing geological experiments with reflectors that show the moon is getting this much further away from the Earth every year due to gravitational interactions, and the Earth is giving an extra microsecond to your year, which you should make good use of. It's extra time caused by gravity. So we definitely went there. But if you're going to question it, it's fine. You can question it in public or with your friends or your family, but just don't question it as this Dutch filmmaker did in the face of someone who actually set foot on the moon when only a dozen people to do so. You don't want me to take off the thing when you did it. How the hell do I have to say that? Get away from me, you're a coward and a liar. So yeah, don't mess with an astronaut. I mean, Buzz is 5'8", Mark Sibrel, the Dutch filmmaker, is 6'7", but you don't totally fuck him. Again, only 12 people have ever stood on another world. That's worth bearing in mind when we're thinking of the grandeur and the achievement of the space program. This is a very select group. But we have been in space, and a much larger number of people have experienced the majesty of zero gravity and seeing the Earth below them suspended in its full glory. So let's look at the state of space, and then let's play forward into the future. The state of space now is, it's a little early to judge. I'm trying to take a historical view here, and we should remember that it's about half a century old. Human technology, the Industrial Revolution, is 7, 8 times longer than that. Human civilization is 10, 12,000 years old. So we have to judge it in the framework of these major epochs of human evolution. And most of it, as I mentioned, was for most of the time the work of 2 countries engaged in bitter political and military rivalry, where the activity was not really being done for altruistic purposes or for the purposes of pure exploration. The number of people in orbit is still around or just under 600. 10 times more people have stood on Everest. Don't take it off your bucket list. That's not that big a deal to climb Everest. Being in space, zero gravity, that's a big deal. 600 people living in Earth's gravity, 2 dozen. Setting foot on another world, 1 dozen. I was lucky enough to give a talk at Space Fest outside Tucson 2 years ago, and they had 9 moonwalkers there. 2 are dead, and Neil Armstrong was still alive but didn't do that kind of thing. And so all the other 9 were there. And to be in one room having lunch with 9 people who stood on the moon, I mean, I don't get dug on very easily, but that was amazing. So that is a very special club. But it's a long time ago. As I said, people forget. People don't think we went. They don't think it's important. They don't think it's relevant. It feels like an anomaly. And there's the problem of how we may have lost our way in space. The biggest major investments the United States has made in space over the past few decades have been the space shuttle and the space station. The space shuttle, which is retired now, 6 1967, when the moon landings were planned, when the final 3 were going to be canceled, America was about to enter a ruinous and expensive war in Vietnam. And Johnson, a very strong supporter of the space program, just realized we couldn't afford it. And so NASA just gone into a different pot in the federal budget. Okay, I know that's not even how it works, but it's just a matter of context, right? You spend your money on the things you want to spend your money on. I mean, NASA has other laws. Industrial complex of China is the Chinese space program is moving by leaps and bounds. And the bottom line here is, again, budget. China's economy, until it tapered off a little in the last couple of years, was growing at 8 to 10% a year for almost 2 decades. That doubles your budget every year. And the space program in NASA in China was growing at the rate of their economy. And you can compare that to the NASA graph I've already showed you. So from a very small start, China has developed a very fully fledged space program. And in the West, people denigrated it originally. Oh, they're just copying American technology. They're not very original. They can't do anything impressive. That is simply not true. The average age of a NASA engineer is 57. The average age of a Chinese aerospace engineer is 27. They have young talent. They're developing their own ideas. Their Long March rocket involves new technologies and innovations not present in any U.S. or Russian rockets. And so they have plans. You can see the density of tick marks at the top, how their number of launches is going up almost exponentially. That's sort of unsustainable, but they're doubling every year. They have plans for a space station, their own space station, at a time when the International Space Station may be deorbited by lack of funding commitments. They have plans for going to the moon. They've already been with a rover, a moon base, a Mars base, and of course, lurking behind of a real concern is the possibility of militarization of space. The Outer Space Treaty of 1967 is the only UN treaty. But if you cede that high frontier to another superpower, especially one that you're not necessarily getting on well with, and especially one whose space development is heavily buried and attached to their military budget, then there's an issue. And by way of contrast, I'll mention something about NASA that, again, most people don't know. When NASA was started in 1959, there was a choice. The military were pushing strongly for NASA to have a military function. There was a strong resistance to a civilian space agency, and it was Dwight Eisenhower, president at the time, and of course a general, who resisted that, and he insisted that NASA's charter have a civilian mandate, have openness, accessibility of records. Now, the Space Shuttle did launch some military payloads, and they were secret, but basically NASA's been a civilian and open public records space agency, and we have Eisenhower to thank for that. That was a very important decision made right at the founding of NASA. In China, that's not the same thing, and we literally do not know all the things they're doing. But the more optimistic, that's slightly ominous, if you like, or somber, but the more positive and optimistic piece that's new on the landscape is, of course, the private sector, and I want to talk significantly about that. And again, it had its start in a way that might not lead you to project this to anything magnificent. Up until 7 or 8 years ago, there had only been a half dozen or so space tourists, and they'd each spent $10 or $20 million a head to have a joyride per week in the space station, taken there by a Soviet rocket, because the shuttle, which you may or may not have escaped your notice, but we're now running on 6 years when America cannot launch an astronaut into orbit without helping the Russians, and it probably hasn't escaped your notice that we're not super cozy with the Russians these days. So that's not a good situation to be in. So the first space tourists were using Russian launchers to get to the space station and paying a nosebleed amount of money, and it doesn't seem to be relevant to anything or anyone else. Charles Simonyi even went twice, and you can add, if you go out for $20 million, just reference this for your dream vacation, you can add $15 million to the $20 million and do a spacewalk as well as have a week in the space station. Nice holiday of a lifetime. But the perhaps more pivotal thing that happened in the same time frame was the X Prize. This is a brilliant idea, and it's not original to the X Prize Foundation. It, of course, was modeled on the prize that was won by Lindbergh in 1927, and the history there shows that 10 or 12 teams were competing to do that first solo transatlantic flight, and they all spent far more than the $25,000 prize that was available for that first flight, and nobody knew how it was going to go. Lindbergh was called the Flying Fool. He was the dark horse. Nobody expected him to win. But what happened, of course, that 1927 is an interesting date, because within 5 years, the fledgling commercial airline industry emerged. Within 10 years, commercial aviation had taken off. So the X Prize kicked into gear something that now transports close to 1 billion people around from A to B effortlessly and without thinking about it every year. That's the model. And so the X Prize was an attempt to kickstart the space program. It was won by Burt Rutan, probably the genius of aviation design of the last century, who took his skills into the aerospace sector, working now with Richard Branson. And it's a repeated suborbital flight of 100 kilometers, which is not to the purest true space, but it's the common line, so it's the definition of near space, and it's truly dark up there. The Earth would look round, it would be black outside the window. So this X Prize was what really kicked the whole commercial space industry into gear. And we know what the high watermarks of it are, but probably what you're not aware of is that there are over 25, more like 30 private space companies that are all doing interesting things in this sector. They all have business models, they all have investors, they have potential revenue streams. They're not doing it as vanity projects. The most prominent ones, of course, are the ones with the most prominent mouthpiece is Richard Branson, because he's a billionaire, very outspoken. He went from an airline, a Virgin Galactic, to Virgin Galactic, and he stole Burt Rutan. It's his spacecraft designer. Now, they've had a disaster just less than 2 years ago with the death of a co-pilot and the near death of a pilot. So they've been stalled by a couple of years from their paying customers. But I think a telling fact of Virgin Galactic is that after that disaster, Richard Branson offered full refunds to all the people who put down total tens of millions of dollars of deposits for flights. It's a Hollywood A-list, as I'm sure you know, Evangeline, Tom Hanks, all these people, celebrities wanting to go up too. And I think he only had 2 or 3 takers for a refund out of thousands of people who put the deposits down. So people know it's dangerous. The people who want to do this, even as a joyride, even as a once-in-a-lifetime thing, understand you could die. It's dangerous, and they are not deterred. That's interesting information at the beginning of a new industry. And as far as people who can
っきりした。ああ、気持ちいい。なんか開いてねえな。まだ1時。もうちょっと。もっと新幹線かっこいいな。どうなんだ、水が。
Reusability is the key, and you need to launch and land your rocket after expanding its fuel and then refuel and relaunch. Apollo was a hugely expensive, expandable for the most part rocket system, and that's what makes it expensive. But Musk was not deterred. He put the video up and said, yeah, sure, we screwed up, we had a disaster, nobody died, these are unmanned rockets. A few months later, this. It's an offshore platform, just in case there is a disaster. Populations are nearby. It's as hard as it looks. It's rocket science. It's incredible. It looks amazing. And this is hard. A rocket equation, phrase, is a bitch. It embeds the fuel, the initial fuel, and the eventual mass, which is mostly fuel, inside an algorithm. And that tells you how much you can accelerate in terms of velocity difference. So look at that curving slope is essentially telling you that for any big rocket, 90 to 95% of its fuel. You're spending all that fuel energy to haul the fuel into Earth orbit, which is part of why it's so expensive. So you need to innovate. You need to make this better, cheaper, quicker. And since we're still using chemical rockets, and all the entrepreneurs that I've been talking about are still using chemical rockets, and there's been no fundamental change there, they're just trying to engineer it to death. And so here, for instance, is the cost per pound of payload or kilo of payload for almost all the launch vehicles over the last century. Here's the place where SpaceX hopes to get with their Falcon Heavy, and they're on the way to reaching this. And it's not just a combination of what it costs to get a kilogram into orbit, it's also getting a big enough payload up there to be interesting. So you also need a significant capacity, so it's a powerful rocket. And this red dot is dropping the cost per kilo by a factor of 5 to 7 on the best available now. And that's a game changer, and that's what all these companies are trying to do, because that just takes it into a new regime. It is dangerous, people will die, but once again, let me hark back to the civil aviation example. The Lindbergh Prize, civil aviation starts in the 1930s, and this is actually, you can't read the scale, but it starts at the end of the Second World War, 1946, and the Lindbergh dots, the circles are just major innovations in civil aviation authority regulations, pressurized aircraft, ultimately redundant safety systems, which several is an innovation in the FAA in terms of civil aviation. But the bottom line is that the fatality rate since the Second War has declined by a factor of 100 per kilometer or mile of journey traveled. So civil aviation wasn't that safe in the 1930s or the Second War, and it sounds so safe, most people just don't think about it. And the expectation, the hope is that this commercial space industry will go through the same process. And yes, there will be some disasters, and some people will die, there'll be learning curves, but eventually it'll be one day. And all of these companies have a viable business model. But there are hazards in space, some are mundane. So let me bring back to how this is funded. Here this will make you feel a little cooler, but here are the growth in the number of billionaires in the world. Branson and Musk have dropped a good fraction of $1 billion of their personal fortunes in this. But the number of billionaires worldwide are worth $7 trillion. And so there are dozens of billionaires who collectively, a small group of them could outspend NASA easily. That just puts it in perspective. And for a type of name, these people are young. They made their money in the sector, so they're bigger around this part of the world. They're looking for interesting and high-tech. So I think we're just getting started on billionaires and spend their money. And I do really a modeling like class. I teach intro astronomy to 18 millennials, 18 to 22 year olds, and I tell them how much of the money that we spend, I assume they're running that calculation, and I tell them how much we spend for either something for 10 years or something like that. If you just plug that to that two numbers, you're still in the top end of the population. So I know you don't
synchronization in the lab CubeSats is just a technology that literally fits in a standardized 10-centimeter cube, and you can gang them together and put a launch payload together where each cube may only cost $10,000 or $20,000. So once again, student groups, single universities can do this. It's not that expensive. You launch them all together and they do their separate thing. And you can see on the right the growth, the exponential growth in CubeSats. And once you get into it, well, then you can attach another venerable technology, solar sails, to the CubeSats, and you're no longer bound to a border making stuff. It's extremely cheap energy for solar energy. So this boom in the miniaturization of space orbital technology is, and of course it just goes against the history of the subject where you build a big, robust, sturdy, expensive satellite, and you can't afford it to fail. It's too big to fail. Hubble Space Telescope, too big to fail, too expensive to fail. With this, you launch swarms of these things, and some of them won't work, some will burn up in the Earth's atmosphere, and it doesn't matter because they're redundant. You just put up lots of them. A lot of Earth-looking science is now being done by CubeSats, and it's very important to the health of the planet to have this kind of monitoring going on. It's doing things that other government agencies and countries cannot or are not doing. And so here is the cost per launch. This is a logarithmic scale, and this shows the three displaced curves show how much cheaper it is to have fully reusable launch vehicles. That's the enormous innovation that Musk and Bezos are trying through SpaceX and Blue Origin and others. It also shows that this gain is going to sort of flatten off at some point in the future. But if you project the cost per person to launch a person, it's going to come down. It's the grand number, if you like. It's not even true, but like over a million. It's going to come down to the tens of thousands fairly quickly, and that puts it on the radar of a lot of people as an interesting thing to do. So I'm going to make an analogy, and I hope I don't force it too much, between the stages of evolution of the internet and the space program. Now, I'll do this quickly. You can get the gist. The pioneering phase, where the people doing this are visualizing things that most people can't even imagine. Like anyone, very few people will know who that is on the lower left. That's J.R. Licklider. He worked at a government think tank in 1960, when the big computer would be the size of this stage. He visualized the wireless internet, data in the cloud, everything we have and take for granted. He visualized it. He talked about it in a position paper. So these are the people thinking way, way ahead. Then you have incubation by the military-industrial complex, which is important because they have deep pockets and they can support it when it's not viable. Then you have migration into the research arena. We know the first web browser came from CERN, which really just does particle physics for the most part. And most scientists, I got my first experience of emailing people who mostly worked in government labs and military institutions back in the mid-1980s. I was using email, never knew what email was. So it comes through this process. And in the internet, we can at least put a time on when things just bust open. In the Big Bang, if you like, 1995. In 1995, a company with the weird name Amazon was founded. In 1999, two grad students not too far from here dreamed up internet search. The first internet service providers started in 1995. And I challenged all of you, because we were all here in 1995, to visualize where we would be now, starting in 1995. I don't think anyone can do that. That's hard to do. So with space, it's very similar. You have the pioneers, the Goddards, where it's very hard to go from Goddard's little tiny rocket, oxygen rocket, to the Saturn V going to the moon. You have incubation by the military-industrial complex, when von Braun secreted back to the U.S. But these are not always easy stories. Von Braun was obviously a Nazi rocket scientist with significant connections to the Nazi Party. He ran the Mittelwerks rocket plant in northern Germany, where 8,000 slave workers died making the rockets. Another 8,000 people died in my homeland, England, for the V-2 rockets. And his Nazi record was completely scrubbed by the U.S. military and the government because we wanted him building our rockets. That's a little awkward, but that's how it happened. So we had these people. Then he went into the research arena, so we had NASA, Civilian Space Agency. And I don't know what the equivalent of 1995 is for the space program. Maybe it's now. It could be now. It could be around now. It's not quite as dramatic as the internet. But I think the same thing is happening, to the point where if we look back 20 years from now, we'll be unrecognizable. And the important other part of the analogy is that the role of civilian research, the role of universities and research institutes in the internet has not gone away. Pushing in the envelope of supercomputers and quantum computing and high-speed internet and fiber is still happening in research institutes. So that doesn't go away. It just means that the commercial enterprise starts to dwarf everything in volume of activity and value. And I do think it's happening now. This is the plot of overall, globally, worldwide, the number of spacecraft of any kind launched into orbit since the beginning of the space age. And what you'll see is that 2 years ago, for the first time, most of the launches were commercial. That's never happened before in the history of the space program. It is happening now as we speak. So I will, therefore, be bold enough to say that I think the Big Bang is happening right now. So let me get to the last part of my talk and talk about the future. What do I think is going to happen and might not happen? I mean, we could be grandiose and excited about what might happen, but space is still hard. Don't forget the rocket equation. Physics still governs all of this stuff. I think we're going to see, first to the Google Prize, the treaty of the moon. There were two treaties. There was the Outer Space Treaty of 65, signed by most of the world's superpowers, luckily, because that's the foundation, that's financing space. There was a treaty of the moon, which actually addressed ownership of space, ownership of asteroids and the moon and all that. And only 4 countries signed it, and major superpowers did not. So you're going to see commercialization of space. You're going to see people claiming to own things. NASA's already twitchy because some of the Google Lunar Prize teams are wanting to go to the Apollo landing sites and trample with their rovers across the sacred footprints of the astronauts. And there's nothing NASA can do about it. It's not a national park. The U.S. doesn't own it. The U.S. has no special rights to it. So you can do anything in space. It's going to be a wild frontier. So that's just something to tuck away there. It's going to be a little crazy. There are going to be sex hotels in space. This is a little awkward to remind you of, but every innovative technology, the internet being a prime example, the pornographers and the sex industry has been at the vanguard of it. Videotape, internet, name your thing. And so I don't think space will be any different. So there are going to be some very unsalubrious things happening in space. And again, no regulation. There's no government agency putting a limit on it or a lid on it. I think we're going to get a space elevator. Space elevator on the Earth is not possible with current technology. What is a space elevator? In very short terms, it's a cable that you build up from the Earth's surface to a point where the centrifugal force is sufficient to hold it against its own weight. And that will be like a superpower. And now you don't have to spend rocket fuel to get towards zero gravity. You're brilliant. This cannot be done on the Earth. It can be done on the moon with 1/6 gravity now with current materials. And it will cost, by some estimates, NASA estimates, $10 billion. That's really not a lot of money. And so companies will gather together and they're wanting to do this because it enables them to take the next step of space exploration using the moon as a staging point. So you have your moon base and then you use zero gravity, which might cost almost nothing to get anywhere in the solar system. I think that's going to happen. It really could happen very soon. And at that point you can mine asteroids. And I'll point out the top curve is the inflation-adjusted price of aluminum, and the Industrial Revolution in the modern age has been fueled by the cheapness of aluminum, which is a finite, non-renewable resource. But if you're talking about the availability of metals, precious metals, rare earths, with high commodity values and finite resources on the Earth, then a 500-meter near-Earth asteroid has several $1 trillion worth of platinum group metals and several $1 trillion worth of rare earths. And we have the technology to land spacecraft on a near-Earth asteroid and steer it into an Earth-Moon
たですね。一本松っていうんですよね。
So if you're wanting to retrain, just bear in mind that Mars is going to be wanting some good people in about 10, 15 years. Until Mars and have it place to go.
Too much
We have to take care of this planet. The minimum time and price tag for turning Mars into a habitable world. If the technology exists to do it in multiple stages, to release enough carbon dioxide to cause a runaway greenhouse effect, to melt the subsurface water, to see the ocean, and then oxygenate the atmosphere, it can be done. But the cost is tens of trillions of dollars, probably, and hundreds of years, maybe heading for a millennium. So that's not going to get us out of any kind of situation. I also don't think we're going to have these wonderful space fields. This was from Space Art of NASA in the 1970s, visualizing tens of thousands of people living in central What was the 1970s and they were smoking? Even NASA they were smoking, so I don't know. Beyond the horizon, it's very hard to tell. So now I'm just speculating. And the last part of my talk will just be speculation. I mean, the fundamental problem is that the fuels are not good enough. Everything I talked about, everything that's on the horizon, everything we're planning and doing is based on chemical fuel. And chemical fuel is tens of millions of times less efficient than nuclear fuel. I mean, what we would get out of a nuclear reactor. So we have to have different fuels. And there's essentially not enough chemical fuel in the universe to get us to another sun at some significant fraction of the speed of light. Can't happen. That's how bad it is, unless we have new fuel sources. In fact, most of the ideas involved with traveling beyond the solar system involve not just nuclear fuel, but capturing the fuel as you go from the thin, diffuse hydrogen in interstellar space and fusing that as you go using huge capturing thermal fuel. So the science for that exists, but we're going to have to do something clever and innovative. So we'll get our fuel from space, and every now and then there are engineering designs for new ideas. Real drive wormholes, science fiction stuff. Many of that stuff. We're going to have to just get our way through standard technology bounded by those good old laws of physics. But you have to be optimistic. You can pull out the history of human transport and see that it does actually project to traveling perhaps in a century or so at a few percent, 5% of the speed of light. And I actually believe that too. I think innovation will get us towards a few percent of the speed of light in 50 to 100 years. That's an interesting number. And that's a number that this project, Voyager Starshot, is planning by using the combination of miniaturized technology, nanobots essentially, and huge terawatt lasers beaming power to these little nanobots attached to meter-sized solar sails to get them up to a 5% of light speed and thereby get to the nearest star system. Fleets of these things, obviously not one or a few. That's an incredibly ambitious idea that was given big public pronouncement. This is the Yuri Milner project, and other luminaries are involved in this. It's a great swing for the fences stretch goal. Why not get to the nearest star system with little cameras and see if there is life on that Earth-like planet in the Proxima Centauri system? Wow, that would be amazing.